Hi guys, thank you for joining. This is Marcos Anasibia here. You're joining the office hours for Autonomous Database for Developers. Basically, we're going to talk today about the building smarter applications with machine learning on Autonomous Database. My name is Marcos Anasibia. I'm product manager of the Oracle Machine Learning. So I have a quick, interesting agenda for you guys. So we're going to start with a quick look at the Oracle Machine Learning product, just a quick overview of that. And then I'm going to show you guys several different model deployments. First, we're going to start with the PL SQL and then doing inference with SQL. Then we're going to do model building and inference with Oracle Machine Learning for Python, so the Python language. Then we're going to move into AutoML UI, and then we're going to deploy a model from there. And finally, we're going to do a inference using REST APIs, using the Oracle Machine Learning Services. And then after that, I'm going to show you how normally a data scientist will use AutoML UI to actually create a notebook. And then from there, they will register a new model, and then they will make changes to the model. And then in a way that they can actually store a new model, and then you as a developer can actually just switch from the model that originally was deployed to you to the new model, right? And you can access both APIs, right? So let's take a look at that. So first things first, the Oracle Machine Learning basic overview. So Oracle Machine Learning is a product that was built for automation to make things fast, right? We have components for AutoML that allows data scientists to build models, and then we actually build a model and automatically identify the models for them. And then you have several specific algorithms that you can use with OML that are in database. So when you're using Autonomous Database, you already have OML in there, and it's available even in the always free level. So it's always there. So what happens is people would like to build models in a scalable way, for example. So you have millions of records and you don't want to use, open source Python or open source R to actually try to build a model with such large amounts of data. So we have all those algorithms built in, and they are absolutely scalable. So we have tested them up to 1 billion records as input data sets to build them. So the idea then is that these algorithms are typically production ready, right? So you build the models there, and now they're ready to go. They are automatically registered with the database. So Autonomous has a model catalog, right, that gets that information in. So as a developer, you can actually query that catalog. You can check which models are available. You can easily then use those models in a prediction, right? So we're going to take a look at those things today. So the different components we have for Oracle Machine Learning are in the screen here. On the left-hand side, we have the Oracle Machine Learning for SQL. That's our native SQL and PL SQL components. But we also have the R and Python languages, right? So these are APIs that we have available. The R language is available on-premise, and it's coming to Autonomous Database later this year. On the right-hand side, you have the Oracle Machine Learning notebooks, and then you have another UI, the Oracle Data Miner UI, which runs on the Oracle SQL Developer desktop product. So it's part of that component. And then Oracle Machine Learning for Spark, which actually runs on top of the Big Data Service. But the two bottom ones are the newest additions to the family, the Oracle Machine Learning AutoML UI, which I'm going to show you guys today, and the Oracle Machine Learning Services, which actually is the REST API that serves real-time scoring of your models. So as a quick look then where things are today, right? So normally at the top you have the Oracle Autonomous Database, right? So we have SQL, we have Python and R coming. But normally what we see more and more is customers asking for a client as well. So they can use, Jupyter or PyCharm or other IDEs, for example, with Python. So that is coming with Database 21C. We're going to have that client for Python as well for Autonomous that we're going to make available so people can use their preferred UI and IDE with OML for Py. And then we have all these other components, right? REST APIs and R and SQL Developer as well, right? So just to illustrate, these are the algorithms that run in database, right? And you can see in red, we have XGBoost coming up as a new algorithm and MSET as well. So these are all the list of all the algorithms that are available in database. All of these guys are scalable. They will run text mining as well, right? They support text and all these other things. So that's just to give you, again, an idea, right, of what we have there. So you guys will have these slides and you'll be able to see this. So model deployment and scoring with OML. So let me show you and explain a little bit of how that works, right, in terms of a developer's life and the DBAs, right? So in general, we have had this kind of process for more than 10 years now. So basically, we have a procedure to build a model in using PL SQL. So on the left-hand side, you see the code there, right? So we have the first thing we're doing is we're dropping a model in case the model exists, right? Otherwise, you're going to get an error if you try to build a model with the same name of an existing model, right? So we drop the model with the name prad_affinity_dt, and then we create a new model. With the DBMS data mining create model 2 that you see down there, we're giving the model a name. That's a unique name. So that unique name is going to then register that model in our database, okay? So I'm passing a query as my input data set. So I'm doing a select star from, right, from a table. I'm giving it a list of options. So those list of options or settings are the vset list that you see on the top. So there's a preparation, automatic preparation for data on, and then the algorithm name, in this case, is a decision tree. And then I have the customer ID, or if the data set has a unique ID, I'm passing that information. And finally, my target. My target in this case is called affinity card, because I'm trying to understand the customers that are actually accepting my offer, right? So I'm building that model on that data set. And on the right-hand side, I'm using SQL to dynamically score and return all of those customers with a likelihood of more than 50%, right, to be a responder. So what that does then is that on the right-hand side, you can see that, for example, because this is just plain SQL, you can use JDBC. So your application can call through JDBC to autonomous database, and then you can get a scoring in near real time. Okay, so you'll get that scoring of the query and the response back to you at the time that the database takes to score that. And normally it's going to be pretty fast. Okay, let's take a look at a quick demo of that. And for that, we're going to use actually the Oracle Machine Learning notebooks. The Oracle Machine Learning notebooks is an interface that we created on top of Autonomous. Again, this is what normally data scientists will use. And it is available, again, on all Autonomous databases, including the always free, okay? So you get to these collaborative UI, and basically this is a notebook interface, right? So let's take a look at that environment, and I'll show you guys around. So basically, once you get into your Oracle Machine Learning notebooks, right, and usually as a user, I will arrive to something like this, okay? I'll increase the font size a little bit here for you guys. And then basically what happens here is I have a lot of different things that I can do. One of the things is the notebooks. So if I go to the listing of notebooks, what I did is I created a brand new notebook right from scratch. And in this case, what you're seeing here is I'm opening that notebook up. I, as a developer or as a data scientist, I have the interpreter binding capability. So normally I can choose, if I want to use the low, medium, or high to develop and run my my algorithms and my queries, right? So normally normally it's the low is okay. If you need a little more power, the medium or high will give you parallelism. that might be important for your project. So the first thing then that I'm doing here is I'm exactly doing what we mentioned. So I am dropping a model. So basically what I'm describing here, and by the way, this is using markup language, right? So when you want to write something like this is what I did, right? I wrote something like that, and then I executed that with this button here, the run, right? And you get these markup language that shows nicely, and then you can add more comments and more information to a notebook, right? But in this case, what I'm doing here then is coming down to the first section. I'm actually dropping a model if the model already exists. So when you run it, and you can see this thing takes 1 second to run or 2 seconds to run. So these things are pretty fast. So when you run something like this, you get then the prediction affinity, right? That's the model I'm going to build. So I called it pred_affinity_svm for support vector machine. And I ran it, and it ran successfully, right? And then on the right, I'm actually building the model. I have a declaration, just like I had on the PowerPoint slides for decision trees. I'm actually building one for support vector machines here, okay? And then when you do that, you do a data mining create model 2, and I'm calling it pred affinity svm, right? Just like the model here that I wanted to originally delete if there existed. And then I'll do classification, right? And then this is my target affinity card, right? And that's my source data, okay? So once that is built, right, I can see it took 2 seconds. So it's pretty fast, right, for these kinds of data sets that are not very large. So when it's built, now I have the model registered with my database, right? And I can do my model inference using SQL. So in here, what I'm doing now, as you can see, I'm actually just running plain SQL, right? So the other one on top, because I'm running a PL SQL, I'm calling it a %script, okay? And now this one I'm running, calling it %SQL. And this is, again, something you can run from a JDBC connection, right, from your application directly. So I want to get a result here, for example, of all the customers. Give me the customer ID, and then give me the prediction, and then give me the prediction probability of that customer being a responder from this specific table. And I want the probability to be more than 50%, and I want to order by descending probability, okay? So if you run this query, you get normally your typical output, right, for SQL. Now, because this is Zeppelin, we built in the capability of running that SQL command and getting back this nicer looking table, right? So because we were running that, then we got a customer ID. This is the prediction. So the prediction here is, yes, this customer is going to buy. And what's that probability based on the model? That's 99.999%. So the guy is really going to buy this. Now, if you keep scrolling down, of course, that probability should reduce, right? Because we made it descending. So you got now a 97% probability, right? So on and so forth here, you're going to get all that listing. Now, there's a detail, which is by default, Zeppelin by itself only allows you to get 1,000 records, right? The first 1,000 records. And that's because you don't want to start listing millions of records in here, because your browser is going to be doing a lot of effort, right? So basically, that's what we're doing at this point. Okay. So very simple and very easy to do, right? Now, having said that, we also have the ability to build that model with PL SQL, but also do inference with Python, right? So now the same process, right, that we were doing again. And why Python, right? So Oracle, we created an Oracle Machine Learning for Python module, right, where we built a lot of functions to process data back and forth, right? So we can transparently access data on a table and use it in Python as if it was a pandas data frame, okay? Now, it is a pandas data frame proxy object, if you will. So you will be able to run Python functions against it, but at the back end, we are actually sending queries behind the scene to the Oracle database. and the Oracle database is solving that. There are many more functions that we built in, and that includes even the AutoML, so the automated machine learning component, and model explainability. So there are a few things that are even exclusive for Python for now. And then there are many, many functions that allow you to write your own code as well in Python open source and then run it. Okay. So let's take a look at and basically how that looks like. So just like before, I built a model on the left-hand side, and I have that model built. In this case, I'm building that model, but then on the right-hand side, I'm using just Python. Okay. So I'm calling a Python function, and then I'm doing an OML sync on a table that is an Oracle database table. And then I'm bringing in the original named model, and then I am doing an inference using predict. Okay. So let's take a look at how that looks. Back to our notebooks then, what we can see here is that we have a model inference using Python, right? So exactly the same thing we saw before, looking like the same components. So the only difference is this time we actually do an import here, do the sync, and then after calling that model, right, the model that I built with the SQL before, I am then doing the inference here with the predict_proba. I have two options in Python. I can do predict or predict_proba. The _proba gives me the probability of each element, right? And that can be very useful because if I have 3, 4, or 5 different classes of things, if I'm predicting good, medium, or bad, right, or high, medium, or low, then I might be interested on those probabilities so that I can get the highest probability and then say that person is going to get the low or the medium, right? So that's very useful here. And then I'm adding a supplemental column here, and I'm adding the customer ID. Why? Well, that's probably your application is going to be sending some data there, and you expect to receive back from the autonomous database a customer ID and those probabilities, right? So that your application can then continue working with that information, okay? All right, so if you go back here then, now we're then doing also the opposite. So we can handle the model building in Python and the scoring in SQL, okay? So again, that's very useful again, because many times data scientists are using exactly that, right? So many times data scientists are using this code, right? Their models in directly in Python, right? That's might be their language of preference. And then in this case, what I'm doing here is I'm creating a model in Python, right? So you can see my steps here. I am building a model with first things first, right? I have to split the model in X and Y. I get to drop the target from the input data set, and then I have to only use the target as a Y, and that's a requirement by Python machine learning algorithms normally, right? So we just follow the standards. So then I'm going to do just what I did with SQL as well, the PL SQL, right? So I'm dropping the model here, right? And I'm calling the model SVM2. I'm dropping the model, and now I am building that model, right? So I'm doing a classification. I'm creating the SVM object, and then I'm going to do a fit on that object, okay? Using just nothing, right? I'm just doing the defaults. I'm not taking any specialty, any special settings here. So with that, again, down here, I get the output of that model, okay? So because I gave the model a name, right? Because I gave the model this special name, that name is going to show up for the SQL as well, right? Even if I don't use the name, I get a randomly generated name, but then it's not easy to find out. So I'd rather use that name so I can find out very easily the model that I built, okay? So down here, you see the model owner, right? That's me, the ADB dev. I have the algorithm name, the mining function, and I see all the settings, right, that I use. Those were the default settings. And this is basically the output and the attributes used on that model and the coefficients and things like that. Okay. So I built that model with Python. Now let's take a look at the inference using SQL. It's going to be the same thing again, right? It's exactly the same, even the same code here. The only difference now is the model is the model number 2 here, which was built by the person or the data scientist using Python, right? So again, data scientists used Python, built a model, deployed it in the autonomous database, and now you can use JDBC to score that model right away. So from your application, you can send a JDBC code and you're going to get the same thing that we had before, right? With the probabilities, and then, the algorithms is the same. So it's going to be pretty much, I expect to be the same exact kind of scores and all of that. Okay. Having said that, normally, as a data scientist, right, we actually give them a little more capabilities, right, to build models and deploy models. So we added just a new interface, and that's the AutoML UI that I was talking about in the beginning. So for AutoML UI, we have exactly this kind of process happening. You get a training data. We actually then going to be running an auto algorithm selection against that, just to check of the algorithms that we have, which ones are actually the ones that might make more sense to solve your problem. And we rank them. Then the next step is saying, okay, pick up the best ranked models, right, or algorithms, and now let's run them through an adaptive sampling to identify whether, we need to sample and we need to unbalance or balance the unbalanced data and check those things. Next step is an automated feature selection. So we're going to denoise the data. We're going to reduce the features by identifying really the most predictive ones. And that's going to improve usually the accuracy. And the final step is going to be the auto model tuning, which is basically after we selected the algorithms, after we selected the best features for them, and we balanced them, we are now doing the final tuning to add fine tuning of the hyperparameters at that point. Okay. So after all of that is done, we can then take a look at the feature prediction impact. So every model, we're going to be able to see what is the rank of the attributes that actually tells us that this model is the best, and then the types of attributes that the model is using. Okay, so depending on the type of model, you might have different set of attributes that show up as the best, right? So this is basically the UI. So it's very, very easy to use. It does not require coding, but I'm also going to show you later the part of the code that we can tweak and add, and the data scientists will probably do some things there. So basically that automates the model building, and then there's a minimum set of inputs that you need, and then you can run this process there. Okay. And finally, after that, we're going to check the OML models itself, right? So as part of our Oracle Machine Learning Notebooks interface in Autonomous Database, we have also the models interface, and the models interface will allow you to deploy the models, right? So we can deploy them from the AutoML UI or from OML models as well. So we're going to see those steps right now. So basically right here then, what I'm going to do is I'm going to come here and then go into AutoML. Okay, right now I have no experiments, right? So I'm going to create a brand new experiment. And I can say ADB developer test or something like that. And then what I'm going to do now, I'm going to select my data source. And just like we did with the code, I'm going to go and go with the same exact one, right? So I'm going to go SH, and then I'm going to go and select supplementary demographics. Okay. So it's the same data set that I just used in my code, and it shows up down here. So I can see what are the columns, right? So I see these are all the columns available there. Okay. Now, all I need to do here as a data scientist is to specify what's the target, right? Remember, I was trying to target affinity card. I was trying to offer these cards for my customers. And then I'm going to go and select a case ID, right? That's customer ID. The only change I'm going to do here, just so that we run it faster, is reduce the number of maximum top models to 2, and then check perhaps my medium service level to go a little faster. Okay, but that's all I need. I don't need to do any other change. The model is going to automatically try to find the best model out of all of these ones. So all the data scientist needs to do at that point is just click start, and I'll go with faster results. Okay. So basically, behind the scenes now, all of that PL SQL code that you guys remember, there's a mix of that with a mix of Python code that is building this automated ML process. And then I can actually see that happening from here. Okay, so if I click on these 3 dots here, it's going to tell me what's the progress, right? So after it runs the algorithm selection, which it just did, it now shows me what are the best, the couple of the 2 models, right? They're the best. So I see naive Bayes and I see a GLM algorithm, right? So this is going to be running. It should finish in around 2 or 3 minutes. And the good thing is all of this is asynchronous. So I can just go out of my experiments, right? And I can see that there's an experiment running, right? So at any time, I can just go back in, and then I can click on my 3 dots and I can see the progress, okay? So it's already down here in model tuning. So now I'm tuning my naive Bayes algorithm, right? And then after that's going to move into tuning the GLM, and the end of the entire process is going to be the feature impact, right? So I already have down here a new column generated by the process, which shows me this is just a general like importance of each variable as a basic variability against the target, right? So it's going to show me a global importance as using a mixture of things that we have already in the database, but we have an attribute importance capability. So it's showing me just like, what are the kinds of variables here that might make sense to try to predict your target, okay? So that obviously saying, if the customer has a home theater package, it's very unlikely that's going to affect whether they accepted your offer or not, right? So we're almost at the end. We finished GLM here, and we're getting to the end of that process. And it looks like the naive Bayes is the winner here, and it's done. So now the process is completed, right? The data scientist can close this off or can click back in the completed to see the steps that were taken. But now, how do I work with this model, right? So the data scientist then is going to say, okay, the first thing I'm going to do is I'm going to click on this model. Normally he will look into the model and look at the prediction impacts, right? So these are the things that the data scientist is going to do. He's going to be interested in these kinds of things, prediction impacts, and then looking at confusion matrix, right, to see how many customers I predicted correctly, right? So I predicted 212 people were going to buy my product when they actually did, right? But I predicted 32 people were not going to buy when they actually were going to. On the other hand, I predicted 63 people were going to buy when they didn't, right? Or they were not going to. So these are things that the data scientists are going to be looking at, trying to optimize these errors, right? And then trying to see what exactly is the cutoff point here that they can work with. Now, but you guys are interested in the deployment, right? So we come down here and we can click on naive Bayes and we can click on deploy. So this deployment is actually going to happen in the Oracle Machine Learning Services as a REST endpoint. So let's try to do our ADB dev affinity model. And then I'll create a new URI that I don't have yet. So ADB dev affinity, okay? And then the version. So I'm calling this model version 1.0, and then a namespace, OML Models, okay? So with that, I'm going to say that the model is shared so other users can use it, but I don't need that. So if I don't check that, only I, as a user, will be able to see it. So I'm going to put share there, and I'll say, okay. So what happens now is that the model has been deployed successfully. That's the message I get here on top, okay? So let's take a look at the OML models then, okay? So if I go now here and I check my models, this is where the model building and model deployment is happening. So these are the models that I have built. And you guys remember, right? I was building a support vector machine, a support vector machine 2. Earlier in the day, I did this one, and I can check the creation date here and sort it by creation date. So you can see that earlier today, I did this guy here. And then I did this two guys now. And then right now, we just ran the AutoML UI, which we use to build these two models, right? So we have a GLM and we have naive base. Now, we selected the naive base as a deployment, right? So we actually deployed that model. Now, notice that I can do it from here as well. So if I wanted to now deploy the GLM one, I could just easily click here, and the same menu is going to show up, okay? So I can deploy a model from here as well, right? So in this case, I can deploy an AutoML UI built model from there, but I can also deploy a model that I just built myself from here, okay? So let's deploy this predictive affinity SVM2 as well. So we can deploy that, and we can say ADB dev, and I'll call manual pred, okay? ADB dev manual, and that just to illustrate and say that's a model that was built by hand, right? I built it with code myself. OML models, and then it's shared as well, and say okay. So now it has been deployed as well, but where does that model get deployed to? So in the deployments here, that's probably the most interesting part for you guys, because in the deployments here, and we listed by date, we can see that because other people have been deploying models, right? You can see a mark, right? OML users. So you can see that other people have been deploying models here. I can see all the model deployments available to me, okay? But in this case, I also see that as an owner myself, right, the ADB dev user, I deploy two models, the affinity first and then the manual after. If I click on the affinity here, I can see the model metadata. This tells me what is this model doing, what's that function of that model. It's a classification model. This is the name of the algorithm. And then these are the attributes. I have numerical attributes and categorical attributes as our input attributes on that model. And then if you scroll down here, you see the output is an affinity card is my output. The output is categorical. And I have two labels, 0 or 1, okay? And then I have a model name, right, that I use to register that. So this is the model metadata, okay? Same thing is going to happen with the other model. The manual model is going to be a classification. In this case, is a support vector machines one that we built. And same thing again, right? Several of these inputs, you got more inputs, right? Because remember, the default AutoML UI was doing feature selection, right? So in the support vector machine one, I did not do any feature selection before putting all of that data. So now the support vector machine says, okay, I need you to give me all of the input data points here, right? The attributes, so that I can score. And it's going to do an output of a scoring of affinity card. Same thing, categorical label 0, 1, okay? Now, how does that look like? For a developer then, what you probably want in terms of REST API is the Swagger file. So if you click on the right-hand side here in the URI, that's exactly what you get, okay? You're going to get OpenAPI you're going to get information about the servers. You're going to get the URL for that specific data center that has the OML server running, and your database, your ADB, and the OML services, right, running for your account. The security is going to be a bearer token. That's what you're going to need to pass. And then it's going to show you all of the different things that you might imagine there, right? So you get output types, any errors and problems that you might find, attributes. So you get all the attributes information right here. The output type, right? So that's the scoring attributes. It's a classification, right? It's an array. You have some labels, right, that will get returned to you. These are strings. And then any details, and then all the security schemes, okay? So with this component then, with this open API information for every model, then you can actually then interact with the models directly on your application, okay? Now notice that I see many other models here, and this is because all these other users have been creating models that are shared across all of this, okay? So I can see not only Oracle machine learning models, right, but I'll see all of the different models, including ONNX models, okay? And that's because the Oracle machine learning services supports ONNX style models, okay? So let's take a look then at the Oracle machine learning services. And what I'm going to do is I'm going to just open up, I have here my Postman, okay? That's one of the tools. I mean, you can use any of the tools you guys might be used to working with. I'm going to use Postman here. And then with Postman, for example, the first thing we need to do, right? We need to ask for our token, okay? So the first step is going to be to do that token. And to send out the token, all I need is, I need to send, this is my Oracle Machine Learning server. That's your autonomous database, right? Wherever it's running, for every data center, we are going to have one OML server there. I need your tenancy. So all of the information about your tenancy in the OSID, the database name that you're using, right? So you're going to have to replace that with whatever database name you have. And then we're going to ask for the token there, okay? So the body, I only need to say, okay, this is the password, this is my username, and that's my password. And then all I need to do is just send that, right? Send that request. With that request, basically, what you get back then is exactly this token, right? So we get an access token that we're going to need to use with OML services for any activities that we're going to do now. And for that, basically what I'm doing here in the tests is just parsing this body, taking the access token and pushing it to an environmental variable called token, right? Just to make it easy, right? So if you look at my variables here, right, you're going to see there's a token here that is, this value matches the new value that I just got, right? Because I need that information. So, and I pre-built a few others here. So I have model URIs and model names and things like that, just to facilitate my own work with these things. But I'm going to show you how that works. So at this case, and in this case, what I'm doing here now is I can then list the models that were deployed. So if I go to my model management deployment, I see all of the different tasks. And by the way, we have a full sample of these tasks at our GitHub that is available there for you guys to go and pick up. You can download this entire set of Postman collections so that you can see how to work with this, okay? So in this case, what happens, I wanted to check the list of the model deployments that exist, right? So all I need to do is I need to pass my token into this this exact URI here, and then I just do send, and that's it. So I get back a list of the models that are there, okay? So I see models, and then what was the user that created that model, the model ID, the model name, what's the URI, and just to make it easier, I created in the tests, I created a bunch of simple things to make it easier to read, right? So you can click on visualize, and you can see it in this way. That makes it easier for us to understand. And so I see a lot of models created by OML user of OML type. There are some ONNX type models there. These are the model names, namespace, right? And then this is the created by. So what I'm looking for is my own user, right? There you go. So I got ADB dev. I got two models here, right, that I deployed. One was the affinity card one, and one was the manually pushed here, right? And I see their URIs are right here. So I'm gonna copy this this URI, right? And just to show you how simple it is, again, I have an entire hour and a half of live labs going through all of these, hands-on lab, going through OML services that we did a couple of weeks ago, so you guys can check that in Ask Tom as well. But for this one, what I wanted to show you guys how simple it is to integrate into your application, right? So as far as your application goes, then you need to pass this information, right, as the body. And then all you need to do here now is to say OML mod v1 deployment. And instead of using this model URI here, right, that I have there, I'm going to delete that, and I'm just going to use the one that we just created, right? We just deployed this model right now, right? So I'm going to go against that model, and I'm going to run the action score. So I'm going to run a post against our model / score, and I'm going to pass this information. The information is my input records are basically this, right? I have age, and I have a few of the variables that model was expecting there. And let's try that. And there you go. So, and then you can see that the first time you're using your model, right, it might take a little more time, like 380 milliseconds. But as that model gets cached by our environment, then, you know, the second and third and the other ones are going to be around, you know, less than 100 milliseconds to score. Okay, so that's pretty fast for integrating into applications. So what's happening now is I got the scoring back, right? I have my probability and my label. Again, I created a little visualization here that can help us. So label 0, I got a 0.95% probability. So very unlikely that this individual is going to buy, and because the probability of 1, which is the probability that the guy's going to buy, is actually only 4.7%, right? So that's basically the process here. Now the cool thing with this, one thing that you guys might not know is that the Oracle machine learning models in database, the ones that are running in database, they are absolutely resilient to any changes and any problems in your data. Okay, so say your application that day was having a problem and you couldn't find the occupation, right? Or the guy did not fill the occupation, and you got now an empty slot there. No problem. You just send, and we score it nonetheless. Okay, it changed a little bit the probability, because now without that occupation, we're now actually estimated the average occupation for that person. So we're just using, in this case, the mode, right, the most frequent occupation on our data set, because we need that data there. But we're automatically replacing that information. And you can say, oh, but what about if I, half of my application breaks down and I can't pass more data? It's fine. It's still working, right? So, and it doesn't matter if your application comes, oh, I have a new version of the application, and now I added my own data here. And that might be, your own new data point, whatever. It doesn't matter. Your application is now sending new columns there that the model doesn't need. It's fine. It works the same way. It's still working. Okay. So the OML models are absolutely resilient to any problems in data, any issues that you might encounter, any problems you might find over here. Okay. Now, there are one other thing that you can do, for sure, many other things, but the second most important thing here is when you click on that algorithm, instead of just sending one record, you can send 2 records like this, right? This is the way to send 2 records. So again, I'm going to come here and then replace this with my model, right? My algorithm, and my model that we just built, and then just send, and there you go. Now you get two, right? You get two customers scored, right? Customer number one, customer number two, okay? And now, just to go crazy with numbers here, we can go normally mini batches, right, of up to 250. So I'm doing 251 actually classifications here. You just send, and you get, in 340 milliseconds, we got back a gigantic list here. You can see all the way down here. So if I visualize it, it's a little easier to see, from customer 0 all the way down to customer 250, right? So that's 251 scores that come back, okay? Now, this is not built for batch scoring, so you can't pass it a table to get it scored, right? But that's the idea. You pass a few records input from your application, and you get back immediately the result. If you need batch scoring, if you want to pass, hey, I have 1,000 records, I have 10,000 records that I want to score right now, you can use JDBC against the same model, right? That's the same way we just did before, where I was passing JDBC, just giving it a query, and then getting back all those results, okay? There are a few other things that we do as well, and this is very useful. And normally a lot of requests we get from customers that want to do this, which is I can get, 2 records here, but I also want to include the top details, the top end details that explain why the customer was rejected or accepted as a good customer, okay? So if I send this now, because I have these top end details, I get the classification, but below that classification, I get the reasons why that customer was classified like that, okay? So in my application, I can have something like this. I get the scoring results, and I get the details. And those details tell me years of residence is actually the variable or the attribute that influenced the most my algorithm here, my model, to say that this customer was not going to buy, okay? And the second most influential column here was Y box games. The third one was customer marital status, then home theater package, then age, okay? But then customer number 2, right, the second customer here, customer number 1, might have something different. So this customer number 1 has an 82% probability to buy. So let's check what were his prediction details, right? In his case, that same column that mattered, right, years of residence, that was important for the first customer, and this customer doesn't even show up. We didn't even bother about years of residence because the box games, bookkeeping, application, education, gender, and occupation are the top 5 attributes that have the highest weights to identify this customer, okay? So having said that, you're going to notice that we have also demos of ONNX models that are pre-built and that are running there. So we have some specific models that you can use and you can run there. And then you can use them across the board from here as well, okay? So if I register a model right now, and I'm going to create the scoring endpoint for that model, then right now I can score a model. And now this is a model built with Python open source that I'm scoring. The same process is going to happen. I'm going to run that, and I'm going to run an ONNX server inside our OML services, and I'm going to give you the scoring, right? The same kind of capabilities, probabilities. But now the model itself, it's an ONNX model, right? That when I was storing that model, you can see it's a zip file that contains an ONNX pipeline model, right? That was a specific model built in scikit-learn. And then I also have an image classification one. So depending on the model that you have there, we have here a model that does image classification. So I can push that model and register that model there, and then I'm going to be able to do the same thing. I'm going to be able to create an endpoint for that model, And then I'm going to be able to then run against a classification, in this case, an image. So I can go back to the image and then, for example, classify a shark, right? So this is a tiger shark. I add that and run that model. And then I can get that the results, right? The result is all the probabilities, right, of what are the model identifying for this shark, right? And normally I'll use something like a top n. So if I add this top n, give me the top 3 probabilities, that's probably better, because then simplifies here. I only get the top 3 probabilities given by that image classification model, right? So again, these are all the things that you guys can do and build with OML services, okay? All right, so we're going, we saw then the AutoML, and then we saw how we can create and registers the models there. I'm going to, we have very little time, so I'm just going to show you guys real quick in here in the back into AutoML, right? When I was doing my process there, when I was doing my my experiment, just so that you guys can see what the data scientists can do. So they can click on Create Notebook, and then I can do an ADB dev AutoML note. And what happens here is now, if the developer, in this case, the data scientist wanted, he can then go into notebooks, check this brand new notebook that was created for him. And inside this notebook, he's going to be able to see what the AutoML UI did, and he can make changes to it. And he can then deploy the model again, okay? So just to show you real quick, this thing auto-generates Python code that will go all the way from the data source and gathering the data, all the way to preparing the data and then building the model. So it's all here, okay? And then when it builds the model, like you see here, it is actually using all of those hyperparameters that we were talking about that the model automatically identifies. They are here. It writes them to you, so you don't have to. And all you do is just run from top to bottom, and you get the naive-based model, the new model built for you, okay? That's the idea. So then the data scientist can come here and say, hey, let me change one thing here. I'll see if I can find a better model if I increase the threshold here. So all of these things are possible for the data scientist, and then he can register the model again, just like we saw. And then you can score the model using your applications again, okay? Using OML services directly. All right. So and that's what we did. So basically, you know, where to go from here, right? We have a lot of helpful links. We have Oracle Machine Learning on oracle.com, lots of tutorials, our own Oracle Machine Learning office hours. We do it that weekly. So we have also hands-on labs with all these things, if you're interested. If you're a developer and you're interested on the REST API, we did an Oracle Machine Learning office hours just for that 2 weeks ago. And you can follow along because we have the zip file with the instructions and all that. And then in terms of office hour sessions, these are our office hours for OML. You can check. There are many that we have done, including Machine Learning 101. So if you guys are interested in learning more about just machine learning, you can just go back there and see that. You can check the developer programs, right? So Developer Live, Cloud Coaching. If you want to talk, you know, something technical, there is a Cloud Coaching there. The Developer Live is also a great resource. And that's that. I'm going to open up to Q&A if there are any questions left. I saw that Mark replied to several questions, but if there are any other questions you guys might want to ask, or Mark, if you know, just let me know.
Okay. Only question remaining is, can you share the presentation doc?
Oh, absolutely. Yes, we'll share the presentation link in the Ask Tom session. So exactly where you guys came in today to see the session, you're going to come to see the slides. So if there are no more questions, then I'll just like to thank you guys for joining us, and have a great day.